to the Q&A segment of Tot 2V. Dear friends, the Big Bang Theory is a prominent theoretical model describing the early stages of the universe's formation. It is the most widely accepted theory to date. According to this theory, the Big Bang occurred about 13.8 billion years ago, and this number is also considered the age of the universe. Of course, many people still do not believe in the Big Bang Theory, because it is just a theory proposed by scientists to explain the formation of the universe. Therefore, you have the right to believe or not believe in this theory. But after all, it is a scientifically verified theory. It provides a comprehensive explanation for many observed phenomena in the universe, including the presence of light elements, cosmic microwave background radiation, the large-scale structure of the universe, and Hubble's law for Ia supernovae. Thus, whenever we explore the universe, we encounter many questions that lack satisfactory answers. That is also the allure of the universe. The more mysterious and incomprehensible it is, the more we want to explore it. So today, Tot 2V invites you to decode the mysterious questions about the universe in episode 14. Enjoy watching the video. Don't forget to subscribe to the Odyssey channel and turn on notifications to all. Now, let's explore together. Subscribe to the Lala School channel so you don't miss exciting videos. Planets orbit the Sun, which is obvious because the majority of the solar system's mass lies in the Sun. It accounts for about 99.86% of the total mass of the solar system. Therefore, the Sun creates an extremely large gravitational field, causing planets and surrounding objects to orbit it. But the reality is that all objects with mass generate a gravitational field. Thus, the larger the mass of an object, the stronger the gravitational field it creates. As for Jupiter, it is the largest planet in the solar system. Therefore, the gravitational force it generates is also the largest among the planets. That is why it is the only planet in the solar system whose barycenter lies outside the Sun's volume. This enormous gravitational influence causes the Sun and Jupiter to orbit a barycenter located outside the Sun. To be precise, Jupiter does not orbit the Sun. Rather, it and the Sun both orbit a barycenter outside the Sun's volume. However, because the barycenter's position is very close to the Sun, and the distance between Jupiter and the Sun is very large, we usually say that Jupiter orbits the Sun. The same applies to other planets. They also generate a gravitational field strong enough to cause the Sun and that planet to orbit a barycenter. That is not exactly at the center of the Sun, but all those barycenters are located within the Sun's volume. Therefore, saying that the Sun is stationary and planets orbit it is inaccurate, because the Sun is always moving around the barycenters created by Jupiter and other planets. This means the Sun is moving in a very complex manner, simultaneously participating in multiple motions around barycenters created by the planets. This binding creates a tight connection between the planets and the Sun. Thus, it forms a balanced solar system as we see today. I have a question. If it and I take a plane to the southern hemisphere, could I see it? Thank you for sending your question to the program. The winter hexagon is a star pattern appearing in the sky in the shape of a hexagon. Its main stars are Rigel, Aldebaran, Capella, Pollux, Procyon, and Sirius. All these stars are in the northern hemisphere, so flying to Vietnam is a mistake. It's summer and you want to observe the winter hexagon, because at that time, the winter hexagon appears in the sky during the day. And of course, during the day, you cannot observe stars due to sunlight interference. Therefore, the only way is to wait until Earth moves to a suitable position, so you can observe the winter hexagon at night. Continuing the program, we move on to Bao Min's question. How can you tell time based on the position of the North Star? As known, the North Star, or Polaris, is commonly used to determine direction and latitude in the Northern Hemisphere. Determining time based on the North Star requires much more knowledge and meticulousness. The Earth rotates on its axis in about 23 hours and 56 minutes, so when observed from Earth. The stars in the sky also take a similar amount of time to complete one rotation around Polaris and return to their original positions. Therefore, each day on a star clock will be 4 minutes faster than actual time. Thus, after 1 month, the star clock will be out by about 2 hours compared to reality. To set up a star clock, you can visualize it as follows. Take the straight line from Polaris down to the horizon as the 6 o'clock hand of the imaginary star clock. Next, identify a star near Polaris to serve as the hour hand. Typically, many people choose the line connecting Polaris with the star Procyon or Gomesa in the constellation Canis Minor as the hour hand. Then, you time it so that the imaginary hour hand points exactly to 12 o'clock on the imaginary star clock. That is, at that moment, the chosen star as the hour hand, Polaris, and the horizon will all lie on the same straight line. At that moment, take out an actual clock and record the exact date and time. According to the rule, each rotation of the imaginary hour hand corresponds to 23 hours and 56 minutes. Based on this rule, you can quite accurately calculate the time in the following days by just observing Polaris and recalling the recorded time reference. For example, if you recorded the time reference as 9 p.m. on November 27th, then the next day, when the imaginary hour hand reaches that exact position, the time will be 8:56 p.m. on November 28th. And when the hour hand rotates to the position indicating 3 o'clock on the imaginary clock, the time will be approximately 11:56 p.m. on November 28th. For subsequent days, you only need to apply this rule correctly to calculate the exact time when observing Polaris. Continuing the program, we move on to a question from you, Bo Con An. Sister, may I ask, why do planets and stars all rotate on their axes? What force causes them to rotate, and what about tidally locked planets? This is also the question from Trong Hu. You asked, why do all planets keep rotating without stopping? Thank you for sending your questions to Hai Yan. This seems like a very basic question in space science. But to understand why planets and stars rotate, scientists still do not have a truly accurate answer to this day. Everything remains at the level of inference only. Accordingly, scientists believe that our Earth formed about 4.6 billion years ago. And Earth's rotation originates from the conservation of angular momentum of the initial solar nebula. This means that Earth and the stars were initially born from huge clouds of dust and gas. Under the influence of gravity, these gas clouds contracted, gradually increasing the density of matter. Until reaching a certain state, they collapsed on their own, forming a large sphere of matter. If the centripetal gravitational force were equal at every position, the sphere created would be very perfect. And theoretically, that sphere would not rotate. But since the spheres created cannot be as perfect as in theory, the collapse due to gravity cannot be uniform in all directions. So during formation, they become imbalanced during the collapse, leading to rotation. Assuming these spheres were born in Earth's atmosphere, then under the effect of friction with air, they would gradually slow down. But in the universe, nothing can prevent the rotation of these spheres. So most stars and planets will rotate throughout their lifetimes. Of course, when these spheres rotate in the universe, is subjected to external influences. They may slow down or speed up. For example, our Earth, because it has the Moon as a companion. The tidal gravitational force from the Moon has gradually slowed Earth's rotation. About 600 million years ago, a day on Earth was only about 21 hours long. But now, it takes 23 hours, 56 minutes, and 4 seconds to complete one rotation. And Earth continues to slow down over time. But it will be a very long time before humans can perceive it slowing down. That is why stars and planets rotate. Perhaps this motion has been inherent to them since their formation. Due to the conservation of momentum, causing them to spin endlessly in the universe. Can you tell me why scientists still know that distant planets are rocky planets? Typically, with current exoplanet detection methods, discovering an exoplanet is not too difficult as scientists have sufficient conditions to observe the exoplanet and its host star. Then, using spectrometers and motion analysis, scientists can estimate the size and mass of the exoplanet through gravitational influence and signals received from observation equipment. Based on the exoplanet's size and mass, they can calculate its material density. Therefore, exoplanets with high material density are usually rocky planets, while those with low material density are classified as gas planets. Subscribe to the Oddity Odyssey channel to see the latest videos.